the last title I took was The Challenge of Intelligent Artifacts, not artifacts. You know, artifacts are some kind of errors if you use a machine, but it's interesting to play with this already here, because in a way, everything what we create from the Stone Age on as humans is an artifact for the archaeologist. And artificial intelligence has, of course, this component in it linguistically, and it's not synthetic intelligence, but artificial intelligence. And the roots of the digital, very short now, are really, really deep. This is from, I think, 1800 before Christ, the mathematics thing. And you know, Galileo said mathematics is a language with which God has written the universe. And I think artists somehow might disagree and say, no, that's not enough. It's much more than math and numbers and figures and geometry, much more. And this is from the Greek. They've reconstructed it as from Kythera. It's a very early machine to calculate astronomical dates, like when is which planet where in the sky, something like that, or when do we have our Olympics. And this is like a clockwork, but much, much earlier than our Middle Ages when we created clocks. And an abacus you already know probably, and this is from Leibniz, who was very fascinated by the Chinese people and especially by the Chinese scripture. He thought it's in a way much more smarter or intelligent, and you see, if you would be closer, you would see that this is binary. It's from the Book of the Changes. In German, Buch der Wandlungen. I think one could translate it, Book of the Changes. Now we have here the von Neumann architecture, the next topic. Computation is a universal enabler. And this is the von Neumann architecture with just the input and the output, and in between the processing. So it's really simple in a way, but von Neumann was absolute genius. He was a prodigy as a child and so on, and people could not come with his speed. When he talked, even the other geniuses did not make it in a way. And what you see is that we have rule-based information processing, and then we have any kind of pattern in the input and some intended pattern in the output. And the difficult thing, of course, is to have it some billion times a second nowadays. Not like when we have a little automator built, it's like very slow. Now it's a billion times or more per second, which is what is rendered here, what is calculated. And so you can actually have all kind of apps and so in this little device, because von Neumann architecture still works, and you can have, for instance, programmable worlds like smart environments, or virtual factories, or digital twins of a thing or a person, and you can have even a metaverse. If you were closer, you would see this is a VR glass here, and this shows an integration of many virtual reality engines into one metaverse platform. But in a way, it's always the same, using math to have functions and to create an output as you intended, because you are the engineer of the machine, whether you are doing AI or anything else. And now the question, of course, is in our times, because we already use on a daily basis, we use AI for recognizing language, like when you use Siri on the iPhone, or when you are using Google Translate on a daily basis. This is all AI working already. But the problem is most people don't know. They have some buzzwords like machine learning, neural network, or supervised learning. But Now you cannot read this here. I will tell you. It's the AI techniques. Yeah, the basis of all, which is enabling then the functional applications, like the natural language processing of the, let's say, Google or Siri agent, is the application. And it's distinct from the technique, of course. And then you have the application fields, like using it for healthcare or for public safety, for instance, or for having self-driving cars. And then the other layer is, it's all an enabling cascade, so to speak. Oh, something went wrong here when I made my slide ready. You have all these buzzwords like smart city, smart health, smart home, smart learning, smart mobility, and so on, because these are the guiding visions, of course, and you have expected values like an increased personalization. And now what are the limits of AI and machine learning today? The thing is, it's really stunning, because when IBM did his blue, was it Blue Mind? Deep Blue. They really had to work hard on it to make it win against Kasparov, who's still living. And Kasparov was defeated by the computer, but on a totally different paradigm than today, when we had, after the AI winter, we had a winter where nothing happened, and then we had a real renaissance of neural networks. And these neural networks can have this quality of kind of supervised or unsupervised self-learning, so to speak. And this means that you, from the company DeepMind, which was acquired by Alphabet, which is the mother of Google, and the AlphaGo learned by itself how to play Go and did win against the best Go player. And Go is much, much more difficult than playing chess. And now the problem is, this is really a big thing, of course, yeah? To have these smart machines which now can translate language in 100 other languages and so on. But the problem still is that we have not found the brain code. And if you compare what's done when you are programming a computer by, let's say, 100 developers creating this chess-playing computer, Deep Blue, or having people creating neural networks, they are like engineers. They are hacking the code so that it happens what it should do. While if you have had a breakfast egg, you know, the egg it's one cell. The egg, what you're eating, is one cell, and if it's breeded, after a while, you have a chicken. Did you know that? That's real. And this is from one cell, and this is the an organism, a totally different thing, because it's self-expressing by the genes, and the genes are often like machine, of course, yeah, there's transcription and all this, but in a way it's totally different from Neumann architecture, because it was developed by evolution, and it's working still today, and day and night when we are sitting here in each cell and so on. And the brain, especially, is always running, never idle. Even when you sleep and not dream, or when you are not focusing on anything, it's highly active. And so it's permanently in the loop with the environment. While what you see here is just input and output. And you don't see here, but you can, of course, you have a lot of input-output loops. This is what you do when you're programming stuff. But in a way, it's not inbuilt in the architecture, while the brain is constantly in dynamics with the environment. Now, a very short, what we do in Foresight is to find out the impact on the different sectors, like society, technology, ecology, economy, and politics. And I'll leave out the ecology, it's an extra thing, and just very, very short to the impact of economy. We have estimates like $14 trillion created by artificial intelligence industries in the next years, and this means 14,000 billions. Yeah, it's a lot of stuff because it will be everywhere like electricity. And the Industrial Revolution 4.0 is, of course, you know, these buzzwords like Internet of Things and physical, cyber-physical systems having new kind of manufactories and so on. And in a way, this is an older stuff you see from 2018. I still use it, and it's in German, sorry for that. But you have some kind of innovation field cluster, like machine intelligence, which is, of course, integrating also artificial intelligence, but it's a bit broader. Autonomous system, innovative user interfaces like AR, VR, XR, and so on. And you have autonomous distributed platforms like what you have today with crypto and distributed autonomous organization or smart contracts, for instance. Also very powerful. And you have digital production and the Internet of Things. And combined all together, it creates, of course, new qualities and synergies. Think about, you have, for instance, avatars which are run by AI. In a future AR, you already do this with when you're gaming. When you're gaming, already AI is creating some noise, some random noise that people have experiences of unexpectedness. So it's already done. And the second slide, and I'm ready with the economy part, is an AI takeover of cognitive tasks for us. Is a deep question, and we have some speculation or estimations. Like you see, it's older, it's from 2016. When will people be replaced? And so the average was by the experts in 2016 that around, let's say, 2060, all human tasks will be replaced. This means are replaceable, yeah. And the problem, of course, is why shouldn't I replace, for instance, a truck driver by an automated car, by an autonomous car, because it's driving 24/7 and will never strike and so on. So it's a real challenge for economy and for the politics, of course, because we call this technological unemployment. This will be a huge topic in the next years. And there's another, let's say, model of fantasy. Short look to the clock, fine. That people now say, because they're so afraid of AI, the PR people have said, okay, we need something different. We call it augmented intelligence, because we are augmented by intelligent tools, and then they will help us and not replace us. But the problem, of course, is if you take, for instance, here this curve of accuracy of studying X-ray medical images, and you have done this for 20 years, and you took 10 years to have this level of expertise to find tumors, cancer in the X-ray image. And that's really, you're proud of it, and you have done this now for 20 years. And now somebody says, no, sir, we have it all here on chip. You are done with that. You can do much better things because it's so boring to do something different. So in the case of the medical expert, he will have interesting other stuff to do, for sure. But the problem remains that you have this balance between augmentation and real deadly, so to speak, replacement. Now, to come to the more interesting point in our context here, the impact on existence and ethics. First, digital tech in general is penetrating all our social life now, and we have research about creating unhappiness from social media and so on. And in a way, I call this as a cluster the post-human alienation. It's very normative, yeah. But we can discuss it, whether it's good or bad. But the problem is that indeed, if you lose your job, of course, you might lose your purpose in some way, some people at least. And so it's also here in the picture And the same thing is if you have social robots which simulate social attention and interest and even social relationship, it's an erosion of the authentic social relationship we have created in our culture. And I call this here also the world of sensons. For instance, if you're building AR or VR worlds, real worlds which are now compared with in 10 years rather low resolution and so on, and it makes you sick to wear the glasses and so after a while. But in the future, it will be probably much cheaper and better. And so you can create with maybe even advanced brain-computer interfaces like Neuralink from Facebook. Or do I mix it up now? Whatever. No, it's Musk. It's Musk. Elon Musk. He has a lot of projects. So he is doing projects on brain-computer interfaces like Neuralink because we are not fast enough for the computer age or the age of AI. So he thinks we need something like this. Anyway, if you create this new interfaces or use your senses as they are, your eyes and ears, it will be very attractive, these worlds which are created because they are created to be attractive. Like an architecture is built so that you feel well in the architecture. And so it might compete with the real world. And I call this the world of sensons because the sensons, of course, are much cheaper. If I have a virtual holiday for 3 weeks on Hawaii, I have nearly no carbon footprint and so on. And of course, this is science fiction fantasy in the moment, but it's for us in the foresight, it's what we do to think to the day after tomorrow. And yeah, of course, you have a kind of complexity overkill already today and loss of privacy. And a real problem is that we are externalizing and delegate the existential decisions of what our life is about. Already we are using in dating portals algorithms, but this is in a way we don't feel that it's kind of toxic because it works. Yeah. We use dating portals and it works. And on the other side, if you go a step further, it might be, in a way destroy our culture as it is. Now the impact on politics also super short. There's an ambiguity symbolized with a plus and minus. And of course, everyone knows it from Cambridge Analytica and stuff, that there is possibility to have surveillance state, surveillance economy, and Rojana Zubov is writing a lot of this stuff because it's so attractive for economy and for politics because it only costs now some cents to monitor people. While if you compare it with the old time of 50 years ago, you needed real people, real manpower, to track people and then to understand what they are writing and what they are doing on their phone and so on. But now it's only, it's super cheap. And so it's a real temptation for politics and for economy to have too much surveillance, so to speak. And the potentials are also here. This is from the World Economic Forum, the risk map, what we have to fear, so to speak. Like, of course, climate action, cyber attacks, data fraud, social instability, deflation, and stuff like this, because they are looking on what's happening to mitigate it when there are collective and global risks. You, of course, have to do something about it. Yeah. And now, think about the potential that you have a risk management on a global scale. You have data-driven real-time adaptation of policies, while now politics is very slow and even does not act in the right direction often. And then you have to understand better the VUCA world with AI and with all the sensors around. and a rising effectiveness and efficiency versus having just symbolic politics, making press conferences, blah, 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 and nothing real happened to solve problems. So this is also a temptation to use AI and ever more sensors and stuff to, even to keep your power, because the citizen will demand that you make rational politics in the future, maybe also more and more. And so you also, it's interesting for us foresight guys, you can have deep future scenarios better than ever, because you have the processing power to look a bit deeper and to understand the systems much better. So now I come close now to the last part. The real revolution is that we have autonomous machines. It's not just that we have smart machines, we have intelligent processing. We have more and more intelligence built into all kinds of devices. And in 5 years, hardly you will find an electronic device without AI built in a way. But this is not toxic, because you can have assisted intelligence, like having, for instance, let's say a smartphone which understands and makes speech to text. Why shouldn't I like this? And this is not toxic, no problem. This is assisted intelligence. You have the human in the loop, which is controlling the stuff. And then you have adaptive systems, like when you have a new workplace, which is helping you to be smarter in your interpretation of data, for instance, because there's so much information. I heard, for instance, about and then we discuss exactly something like this. The real problem could be the autonomy, not the automation like a washing machine, but having full autonomy. Because, I have it, I've written here. You see here, this is a famous, rather famous picture. Autonomy by definition means out of our control. Don't let any engineer tell you, hey, it's no problem. We have transparent AI. We make it explicit. It's called the project XAI, explainable AI. Of course, we need this. At least we need that the machine is transparent and is not totally going astray like a driving car killing people. So you need transparency for the self-driving cars, of course. But in a way, I was on a forum discussing this AI ethics stuff, and the name of the room, it was on Clubhouse, was the impossibility or the illusion of explainable AI, and it was done by a AI professor from the Bay Area. So coming close to the end now, these are famous quotes now, already 6, 7 years old. Hawking, who deceased some time ago, said, humans limited by a slow biological evolution couldn't compete and would be superseded by AI. Elon Musk, AI is our biggest existential threat. Bill Gates, I'm in the camp that is concerned about super intelligence. And we have a lot of literature now about how big is the threat on an existential scale, really endangering our mankind, the species of Homo sapiens sapiens. And I call this singularity hard and soft, because maybe we all have also a soft singularity, kind of. And for instance, here, it's not easy to read from a distance. The AI companion who cares, and here she says replica is a conversational AI. Can't wait to see the world through your eyes. And then on the other end of the spectrum, this is very soft, and you have therapeutic apps today which are also using AI, and they work against depression and so, no problem. I only can point to the spots that we have to debate probably. And then of course you can add to this nice Spot Mini from Boston Dynamics a little killing feature, which is easy, that it has a teaser or can kill people because it's already autonomous. And of course you have this also about military killer robots, super soldiers and so on. And now the point is here, now really the end, open questions. AI confronts us with the questions of meaning. If there's something missing, individuality, and as mankind. And so we need exactly this debate, and it's difficult because it's about the whole mankind also. There's a challenge of pluralism of our value sets. We are not the same. We behave so different in Asia with, for instance, the virus compared with Latin America or Europe. And so maybe we even need AI to find a way to bring this discourse into a form, and then it's a recursive construction maybe. And this is very irritating if you have got this from, it's from MIT, the Moral Machines project. And in a way, we are definitely overwhelmed by what AI is bringing to us as new ethical dilemmas. We had never something like this. We are talking about triage, for instance, in our context today. So we had ethical dilemmas, of course, but not in this ugly way. So, for instance, medical support, self-driving cars, you have to decide as an engineer or an automotive producer who is building self-driving cars in the future, and we are now on level 3, and the project is to have no steering wheel in the car. This is level 5. And then you have not even the possibility to stop the car because there's no steering wheel, there's nothing. And in level 5, the car has to decide to kill the baby or the grandma. That's the fact, and nobody can deny it. You can only avoid to build such cars or to have something like random also, but it's really overwhelming us. So what actually is, when we hear in the news AI ethics, the word here is AI ethics, is already AI politics, because it's often about interests and not about really philosophical reflections. It's about, oh, I feel biased, I feel offended, and so I feel there's injustice in the... This is not ethics, it's just politics, sorry. So we already are in the stage of having AI politics. Now what we need, because we are in such a confusion, in my point of view, we are in ontological confusion or metaphysical confusion. For instance, you know, and I would say, I know that Japan is so different. They have a different perspective on things, and we call this in the ethnographic world animism. Yeah? They are much more easy to say something is living and has a soul than we or Europeans are. So take this aside, because these are Japanese elderly people who are having this pet, this AI-driven pet, which is interacting with them. And it's also in research that we have attachment to robotic creatures. After a while, people don't feel good if they should destroy a robot. It's only a stupid toy robot, but they say, no, I don't want to destroy it, because all the day I had fun with the robot. So it's irrational, but it's real. And Thomas Metzinger is researching about consciousness and the evolution of consciousness and stuff. He calls it social hallucinations. And then we have the thing with the language. We use, for instance, if I see now, what should I use? Let's say this is a robot, and it has eyes. And I would say, because the eyes are here, now the eye sees the flowers. Because we have no other language. Of course, we use the word see, perceive, hear, acknowledges, identifies, classifies, and so on. So our language is no longer valid for this world. We only can contextualize it and then understand, of course, I did not mean this literally, because here this should be a robot, which is just a von Neumann architecture of a kind. And this is the real thing, let's say an animal or a human being, which has what we call in philosophy qualia, which is perceiving something, which has an awareness of something. And this is an old philosophical debate. Anyway, the problem is if we start to integrate our robots, because they are now also called social robots, some type of, into our life, we will start to integrate them into our mental models. And we will behave just like them, as if they are human. This is really challenging, because the best thing, in my perspective, of robots and this kind of machines is that they don't feel anything, so I can do with them what I ever want, and this is a great advantage.